Hi, I'm Vedant and I'm from Wilcox High School, and this is my video for Milestone 3. So for Milestone 3, my goal was to get the actual code working for the bot. So this means that the computer vision model has to work and recognize the red ball, draw bounding boxes around the red ball, and actually move the bot to track the red ball as it moves around, and stop when it reaches like a certain distance away. So for this milestone, it was mostly software, because in my previous milestone 2, I had already finished all the hardware and assembly. So this milestone was essentially all software. And what I had to do first was get the OpenCV model to recognize the red ball and draw bounding boxes around it. So if you see here, I took a screenshot of the program output. So it draws bounding boxes and it fits the shape to the red ball. So this was right after my milestone 2 ended. So the program wasn't as accurate as it is now. But as you can see, it misrecognizes this, but it still draws like a smaller fitting box around the smaller red ball and a larger fitting circle around the larger red ball. So basically, it dynamically is able to change the shape of the bounding box. So after that, I actually had to get it to move according to what it saw. So basically, how this works is when it detects that the ball is like a little bit off center from the frame, the amount it's off center is called delta. So it turns the bot until the delta amount is like 50 or lower. So like for example, if the bot was if it was off centered like this, the bot would turn until it's more like facing towards the center, and the delta or offset value is less. So I can give like a quick demo of that here. So if I run the code, it should, after a while, and it loads and detects a ball, it should track the ball and stop when it reaches the ball. And it also runs like a web server in the background, so I can open it in browser and see what the bot is seeing. And as you can see, it's drawing a bounding box around the ball. So this is what the bot sees. And as you can see, as the ball is moving around, it's recognizing the ball. And in the terminal window over here, it gives you all the statistics, so the delta value, the coordinates of the ball, and everything. So essentially how the OpenCV model works to detect the ball is it detects it based on color, and then it erodes the image, which means it makes the image a lot lower quality for processing, and it wipes out all of the background elements and anything else besides just the ball and the color of the ball, which is called a mask. So based on that, it determines the coordinates of the ball and turns the bot to track the ball. So the main challenges during this step was actually getting the OpenCV model optimized, because I'm working with a Raspberry Pi, which has a relatively low processing power. So I need to make sure with the web server running, and the web server is constantly processing images, and the camera itself is also constantly processing images and spitting them out. And you also have to power the motors on the bottom, and the ultrasonic sensor has to be powered too. There's a lot going on, and I need to make sure my code was optimized so that it didn't take too much processing power and start lagging, because in the beginning I was facing a lot of delay. I would move the ball, and then 20 seconds later the video feed would actually upload and the bot would move to that position. So I had to do a lot of optimizations and lower the resolution and everything so that it could actually be in real time, so the bot wasn't turning 20 seconds later than it was supposed to be turning. So that was probably the most challenging part. Another difficult part is probably wire management and everything. It's a pretty common problem with a lot of these kinds of projects, managing all these messy wires. So for my next modification milestones, I look forward to fixing all of the wires and moving this onto a new chassis, and having it able to detect pieces of trash and pick them up instead of just the red ball. Thank you.